Hello. So this time we're going to go over an application of the conjugate trick to calculate some particular limits. So for the moment, let's suppose that we're interested in computing this limit given as a fraction that also contains a radical expression. Well, the first thing that one would try is a direct substitution, right? But it doesn't work. So note that direct substitution doesn't work, right? Why not? Because direct substitution leads to the following expression. 2 plus 14 minus 4 divided by 2 minus 2. But this is undefined. Simply because we have a division by 0, right? Well, what can we do? Look, note also that the numerator has the form a minus b. So look, if we multiply it by a plus b, we would get something of the form a squared minus b squared. Now you may say, why is that this might be useful? Well, look, the expression that we have here is a radical. But if we square it, we will get rid of that radical sign. So why don't we give it a shot? Well, let's see. So now we have the limit as x tends to 2 of the square root of x plus 14 minus 4 divided by x minus 2 should be the same as the limit as x tends to 2 of the square root of x plus 14 minus 4 divided by x minus 2 times, well, the square root of x plus 14 plus 4. But now I have to be careful. It should be divided as well, but the square root of x plus 14 plus 4. This is nothing else but what I would like to call a fancy 1. It's just a fancy way of writing 1. Right? Multiplying by 1 doesn't affect in any way the value of an expression. But, well, it could be of great help. So now I'm going to multiply. But this being a difference, right, just as the one that we wanted, it turns out to be this. This is the limit as x tends to 2 of the x plus 14 in a square root, now squared, minus 4 squared. Well, now divided by x minus 2 times the square root of x plus 14 plus 4. Of course, now, since we're only considering the case when this square root is on x being larger than or around 2, well, that means that the number that we have here now turns out to be this. This is the limit as x tends to 2 of x plus 14 minus 16 over x minus 2 times x plus 14 plus 4. Okay, look. But what is this? What is x plus 14 minus 16? Well, that is x minus 2. So this is the limit as x tends to 2 of x minus 2 over x minus 2 times the square root of x plus 14 plus 4. Okay, now, but look, Since we are very close to 2, but never equal to 2, we are able to do this cancellation. So this we have the limit as x tends to 2 of 1 over the square root of x plus 14 in a square root plus 4. And now I think this is prone to a direct substitution, because from here we can simply say, look at this expression. This is a continuous expression on x, as it's been just a radical with a fraction, right? So what should this be? Well, this should be the square root of 2 plus 14 plus 4, which is equal to 1 over the square root of 16 plus 4, which is just 4 plus 4 in the denominator, which is just 1 over 8. Now, what would be a good indication that this trick may help you? Well, look, this undefined expression, although there's nothing that you can do with it, right? There's no value. It provides certain data. Look, the denominator here is 0, but also, as you can see, the numerator is also 0. So it has the form 0 over 0. That indicates that somehow the expressions here and here have a common factor, something that you can take out. So I hope that you like this and you enjoy it. Take care and subscribe.